In this video, I'm going to go over some frequently asked questions about VRF. Last week, I was asked to be a panelist on a presentation for VRF. Basically, all I did was monitor the chat and answer any questions that came from the audience, and I got some pretty good questions and I wanted to share some with you today. So the first question I got was, what is the most cost-efficient VRF system? Now that question is kind of hard to answer. It really depends on the application, and you'll notice that this answer is pretty typical when it comes to a lot of these VRF application type questions. It really does depend. So I represent Carrier, which has a 2-pipe and a 3-pipe VRF system. So it really gives us the flexibility to use the different types of technologies. So it really does depend. If you have a small 1 to 2 story kind of wide building, I would say 2-pipe is the most cost efficient, where you can put a central MDC controller box in the central area of a building, and then you can pipe the other fan coils to the different zones that it has to serve. And that way you're minimizing the amount of refrigerant pipe, and with a 2-pipe system, you're also minimizing the number of brace points, since you only have 2 piping connections per fan coil. Whereas on a 3-pipe system, it may be more cost efficient when you have, say, a mid-rise commercial building or like a hotel building, where it wouldn't be feasible to put a big central MDC box, and it might be more cost efficient to put a multi-port flow selector box, where you would go down from the roof to each floor, have a flow selector box, and then zone out to the different rooms, and then go down to the next floor, and so on and so forth. So basically the short answer is it depends. The next question I got was, can we increase the line length limitations set by the manufacturer? How do you address multi-level buildings where the vertical line length limitation is less than the total height of the building that you're trying to serve? The short answer is no, we can't increase the line length limitations. Those limitations are there to help the equipment run properly and to ensure that the equipment runs for a long period of time to basically meet the 15 to 20 year life expectancy of a VRF system. So how do we address multi-level buildings where the total height of the building is above the vertical limitation of the equipment? The easiest way to do this is to space out the VRF systems throughout the height of the building. So typically what we'll do in this type of application is we'll have a number of VRF systems up on the roof, and then we'll pipe down to however far down we can go. And then we'll have, say, a mechanical floor. Well, we'll put more VRF systems there, go down another number of floors, another set of VRF systems on another mechanical floor, and so on and so forth. So that's the easiest way to address a multi-level building, office building, or a tall residential tower. Next question that I got was, how do you address outside air or ventilation requirements? How do you address introducing outside air or ventilation in a historic or in existing buildings? This is one of the most common questions that I get when it comes to VRF. Depending on where you are, here in California, there's local code that requires a certain amount of outside air to provide fresh air ventilation into the space, depending on how the building is used. And how do we do that? The easiest way to do that is with a separate DOAS, or dedicated outside air system, whose only job is to bring in outside air, temper it, and then bring the outside air and distribute it through the inside space. When it comes to historic or existing buildings, with existing buildings, if there is an existing rooftop or a system that's already bringing in ventilation air, the easiest way to address that is just to use the existing ductwork. Maybe you'll have to replace the outside air system with a newer DOAS, but if at all possible, reuse those ducts. It saves time, it saves money, and it's already there. And anything to make the job easier is okay in my book. When it comes to historic buildings, and maybe there isn't a existing system for bringing in outside air, the easiest way to do this would be maybe you can address it with operable windows when code allows, or there are certain fan coils that will allow you to bring some outside air. For example, ductless cassette fan coils will usually have like a small knockout on the body of the fan coil, maybe like a 3-inch hole where you can bring in some amount of outside air. But keep in mind, this is only like a small percentage. Typically it's 3 to 5%, or maybe even less than that, of the total CFM of the fan coil. So, and it's also not conditioned and it's not filtered, so you're going to have to somehow filter, make sure that bugs or anything like that doesn't come into the fan coil. That's one way to address it in a historic building. Another way to address outside air in a historic building, I know there's some manufacturers out there that make through the wall energy recovery ventilators, where you'll bring in some outside air, run it through some sort of ERV core, where you can do some actual energy exchange and filter out the air and bring it into the space. And they have these for single rooms, which is useful for apartment buildings or maybe office buildings that have direct access to the outside wall. So that's another way of bringing in outside air in a historic building. How do you address ASHRAE 15/34 requirements? So this ASHRAE requirement it's there to protect users or occupants from potential refrigeration leaks. Basically, it dictates how much, if there were to be a refrigerant leak, it dictates the minimum volume of a space to where if there were a refrigerant leak, that it wouldn't possibly kill the occupants. So if you have like a larger VRF system with that you have to add pounds and pounds of additional refrigerant, that code dictates the minimum volume of that room. So the larger the system, the bigger the minimum volume has to be. So how do we address that with VRF systems? The easiest way, I think, is to if possible, to split that VRF system into 2 smaller VRF systems, so the total amount of refrigerant is less per system. So by doing that, you're able to increase increase the minimum volume of the smallest room in that space. Another way to kind of address this is to use transfer grills between 2 adjacent rooms, so your minimum volume is essentially those 2 rooms combined. That's another trick to kind of address the ASHRAE 15/34 requirements. Another question that I got during the presentation was, do you have a drop-in A2L refrigerant? The short answer is no. So I represent Toshiba Carrier and Carrier here in Southern California. And the short answer is no, we don't, but we are working towards a refrigerant change come 2025, 2026, I believe. And the refrigerant that we're probably going to go towards is R454B. I know R32 is the refrigerant of choice for some of the other markets in the world, but here in North America, it looks like we're going to be moving towards R454B. So right now, we don't have a drop-in refrigerant. We're going to use R410A from now until we're required to make that change. And when we do make that change, it's going to be R454B. And finally, one of the more nuanced questions that I got was, why use VRF versus a chiller, boiler, air handler system? Now, this has been always a question ever since VRF was first introduced, especially here in the States in the mid-2000s. Why use VRF with all this refrigerant piping versus a tried and true chiller, boiler, air handler, cooling tower system? I remember I did a lunch and learn on this, and my best argument for using VRF is mainly to use, it's a better use of space. If you take a look at a let's say a central chiller plant, or even just like just a whole mechanical room with a chiller, a boiler, and all the required accessories when it comes to a chilled water system, you have obviously you have your chiller, you have your boiler, your air handler to move the air throughout the building, and then you have a cooling tower. You also have pumps, you also have VFDs for those pumps, and you also have the chilled water and hot water supply and return piping, which depending on the size of the system can be 8, 10, even bigger inches in diameter. And with the VRF system, your medium of transferring heat gets replaced with refrigerant, and refrigerant is more energy dense, if you want to call it that, in moving heat from one area to the other. So typically your refrigerant pipes are at the biggest, like an inch and a quarter. Most of them are like inch, 7/8, 5/8, 3/8, what have you. So even if you have multiple fan coils and their associated refrigerant pipe going up and down a building from the zone that they're serving up to the roof or wherever the outdoor unit is, even if you group all those refrigerant pipes together, it's only going to be, maybe say like a 12 by 24 foot refrigerant piping chase that you're going to have to dedicate, versus, each chilled water supply and return pipe, which is like maybe 8, 10, 12 inches, maybe even bigger. The space required to move all that refrigerant is definitely less than all the pipes that are moving chilled water, hot water, supply and return around. Also, I would argue that the space for the outdoor condensers is going to be less than your chillers, your boiler, your cooling towers, and your air handlers combined, because each space has its own fan coil, which it's going to be, depending on the fan coil that you use, it's either a high wall or a cassette, and maybe at the largest an 8-ton fan coil. It's going to be a lot smaller than a huge air handler. So you've got the advantage of using a fan coil for each space, and then each outdoor unit is going to be much smaller than your cooling tower, air handler, whatever else you have up on the roof. And you get rid of pumps, you get rid of VFDs for those pumps. If you ever walked into a mechanical room with all the the chillers and the pumps, it takes up a lot of space. And if you compare that to a VRF system, it's definitely a lot less space. And the argument that you would make to a building owner is that you can use all that space, dedicate maybe an entire mechanical floor. You can now use that for leasable space, which means more money for the owner. So that'd be my argument for using a VRF system versus a chiller, boiler, air handler system. So those are the questions that I got during the panel. If there's a question that I didn't answer that you have, please leave them in the comments below. Please do me a favor, if you like this video, give it a thumbs up and subscribe to my channel, and I'll see you all in the next one. Thanks.